These notes are for Honors Math 3. This is Unit 9, Objective 11, and we'll be learning how to sketch tangent and cotangent today. So I've set up here where we're going to be working on each one. We're going to start with the graph of tangent. And we're just going to, like we found sine and cosine, figure out the graph just from some specific values. So we're going to start filling in our table here with 0. So tangent of 0 is 0, which gives you a point on the origin. If we move to pi over 4, tangent at pi over 4 will give us 1. So I've marked it off here, pi divided into fourths. Tangent of pi over 4 is 1. When I get to pi over 2, tangent at pi over 2 is 1 over 0 and is undefined. So just the same way we did with secant and cosecant, we're going to draw a vertical asymptote here at pi over 2. Now, when we draw a period of tangent or cotangent, we want to draw between a pair of asymptotes. So you might keep going with this into 3 pi over 4 will get you to -1. 3 pi over 4, -1. Tangent of pi, 0. The next value at 5 pi over 4, we're back at 1. And then here at 3 pi over 2, tangent would be undefined again. So you'd end up with another vertical asymptote. So there is a period of tangent that exists right through here in between these two, but we wouldn't say that that's the first period of tangent. We want to deal where the origin is, so we're actually going to work backwards here. At negative pi over 4, tangent is -1, since we're in quadrant 4, where tangent is negative. And then negative pi over 2, again, tangent would be -1 divided by 0, and so it's undefined again. So we would end up with a vertical asymptote here along x equals negative pi over 2. So the first period of tangent is between these two vertical asymptotes. And what's going to happen is it'll follow in this way. And out up here. So that is the first period of tangent. These asymptotes are at negative pi over 2, positive pi over 2, 3 pi over 2. And so what you'll notice is right here, the graph will repeat itself. And when we're looking for the period length of any function, we're looking for how often until it repeats. And so this period length is pi. And so the period length for tangent is always pi divided by b. So this is the first time it's been different from sine, cosine, secant, and cosecant, which all have a period of 2 pi over b. This is just pi over b. So let's talk about the domain. So we were practicing this with secant and cosecant, and we're going to write it the same way. We'll write what x cannot equal. So we'll start here with x cannot equal. And since 0 is not an option because x can be 0, the first smallest positive value I can choose is pi over 2. And then we just want to add on to that how often do I have another vertical asymptote? So every time we add on pi. So we write pi k, where k is an integer. So looking at the range and the y values, that would be all of these outputs here. You'll notice that we're getting all of the values out here. So all the negatives, 0, all the positives, and our range is going to be all reals. Now, when we go to sketch tangent graphs, we want to remember what this graph looks like, but we actually base it off the asymptotes first. I have found that that's the best way to start these sketches is by finding the asymptotes. So you'll notice that the original asymptotes are at plus and minus pi over 2. So it's really that the asymptotes will be at x equals plus and minus pi over 2b. So it looks like the period pi over b, and we've just cut it in half since it's half on the right and half on the left. But besides that, we want to adjust for any translation. Now, a vertical translation won't disturb my vertical asymptotes, but a horizontal translation will. So this is how we'll go about graphing our tangent functions. We'll start with the asymptotes here at plus and minus pi over 2b. And b, again, is just that value, the coefficient of x. And then we'll add the horizontal translation. So we might shift right or shift left, so we might add or subtract a value here. Once we have those values, what we know is to divide those spaces in half. And we'll plot a point right here in the middle, and it should be on the x-axis unless there's a vertical translation. So if there's a plus 3, we would move this point up 3 units. Okay, a minus 1, down 1 unit. To plot the other 2 points, just like you did with sine and cosine, you divide the remaining spaces in half. And then this is where you'll use that leading coefficient a. So you'll notice the distance from this point up or this point down is 1 unit, and that's my leading coefficient 1, that a value. Okay. So the last thing we want to remember is if there's a negative in front, what would negative tangent look like? So when you have a negative in front of your function, so a negative f of x, negative tangent, or negative x squared, it's reflecting your graph over the x-axis. So you'll notice that positive tangent here is an increasing graph from left to right, which means negative tangent would decrease. And so we might see that. All right, and so those are all the basic things you need to know. There are still 5 key elements when you're sketching a tangent graph. So with sine, cosine, you have 5 key points. When it comes to tangent, you'll have 2 vertical asymptotes and 3 points inside. And so we still have the 5 key values when it comes to sketching. So we're going to move down and look at cotangent. Now, values here, very similar to tangent, starting with 0. Cotangent at 0 is x over y. So here we have 1 over 0, which is undefined, and we already have our first vertical asymptote on the y-axis. At pi over 4, just like tangent, pi over 4 is 1. The reciprocal is still 1. At pi over 2, cotangent now is still x over y, so 0 over 1 is 0. At 3 pi over 4, cotangent is negative 1. And at pi, again, undefined. So I have these values here. After pi, we start repeating. So the next value, 5 pi over 4, would be 1. 3 pi over 2 would give us 0. 7 pi over 4, negative 1. And at 2 pi, we'd be back to undefined. And so again, we would just keep repeating these values, which tells us that the period of cotangent is just this, pi. And the formula for finding period of a cotangent graph is pi over b, just like it was for tangent. So our graph will come down this way and continue down toward this vertical asymptote. You'll notice positive cotangent is a decreasing graph. So backwards from what tangent did. And that tells us if it switched to negative cotangent, we would have an increasing graph. So again, that reflection over the x-axis would cause it to appear to be increasing. The domain, so every pi units, we would get the graph to repeat. So I could get the same graph back here, negative pi. We could take it out to the right as well, but remember we could go both directions here. So taking it to the left, okay, a negative pi over 2 would be a 0. And we want it to repeat, so we start with a up and then down 1 unit, and it will decrease through here. So my domain, x cannot be negative pi, 0, pi, 2 pi, negative 2 pi, and so on. So it's just every multiple of pi. So you might think of it as x cannot equal 0 plus every pi units. But to write 0 plus pi k is unnecessary. So we'll just drop the 0 plus and write pi k. And again, k is an integer. The range is still going to be all reals. Now the asymptotes are a little bit different. You'll notice this time there was one right here along the y-axis and then one at pi. So the first asymptotes are at 0 and pi over b, since in this case the coefficient x is 1, so b is 1, and so the asymptotes were at 0 and pi. Now you want to, like last time, add on the horizontal translation. So if the graph is shifted right or left, that will, of course, affect where the asymptotes end up. So we want to do one of these examples so that we can see how that happens. So I'm going to grab a problem from the 9.11 assignment, number 6 from your worksheet 9.11. So as always, we want to factor that b value out first. So you'll notice there's a translation left 1/3 and a translation up 1 unit. So the period length here, we'll take pi and divide it by b, pi over 2. So pi times 2 over pi comes out to 2. So a period length of 2. What we actually want to do first is graph by finding the asymptotes. So we're going to start there. So your formula for asymptotes for a tangent graph are plus and minus pi over 2b, and then we want to add on the horizontal translation. So that's 1/3 to the left, which means we'll want to subtract 1/3 from this value, from each one. So we start by plugging in the value b. So b was pi over 2. So that 2 over 2 reduces, pi over pi reduces to 1, and we're left with plus and minus 1 minus 1/3. 1 minus 1/3 is 2/3. -1 minus 1/3 is -4/3. And so with a period length of 2 units, my asymptotes are from -4/3 to 2/3, which is a distance of 2, right, under that translation. Now, the vertical translation will apply to the points inside. Once you've adjusted where the asymptotes are, the points inside have translated left with it. So the only other thing we have to do now is shift them up 1. Okay, so we'll start with the asymptotes at -4/3 and 2/3. So I'm going to mark those off. So I just made markings every 1/3 unit. And so we have that total distance of 2 units for the period length between them. So the points inside, we want to divide these spaces in half. So we're going to start with our center point should be right here at -1/3, but it's been translated up 1 unit. So notice that if this tangent graph had not been translated left, it would have started with the center point on the origin, but because it was translated left 1/3, so we end up here at that -1/3, which is in the middle of the asymptotes, and then we translate that point up 1 unit. So that's our center point. So we only need the other 2 points. So we want to divide the remaining spaces in half. So it looks like we're going to go with these markings here. Now you'll want to note that this is a positive tangent graph, so it should be increasing left to right. So when I go to the left, you want to go down to plot a point. When you go to the right, up to plot a point. So how far up and down is the A value here? So similar to using the amplitude. So 1 unit, so in line here with this X value, 1 unit down is on the x-axis. Over here to the right, 1 unit up gets us up here to 2. And so here is our tangent graph. Okay, so let's look at one more of these, number 12. All right, so I have negative cotangent of x plus pi over 2. So cotangent is a decreasing graph. Negative means it will be increasing. So there's no b value to factor out. The b value is 1, and we want to undergo a translation of pi over 2 units to the left. We're going to start by finding the asymptotes. And for cotangent, those are at 0 and pi over b. And then we'll subtract pi over 2 from both. So pi over b is the only one that's going to need to be evaluated here. b is 1. So I have 0 and pi, and then I want to shift them left pi over 2. So 0 minus pi over 2 is negative pi over 2. Pi minus pi over 2 is positive pi over 2. All right, so we'll draw in these asymptotes here at negative pi over 2 and positive pi over 2. Notice that there is no vertical translation, so right in the middle here, we should have a point on the x-axis. we'll divide the remaining spaces in half. So halfway between the left side asymptote and this point, negative pi over 4, we want to go down, so left and down. So how far? That's the a value again. And again, that a value. Well, it's a -1, but the negative just told me that my cotangent graph will increase. So it's the 1 unit down that we'll use to plot a point, and 1 unit up to the right to plot a point. So notice that this graph looks just like the graph of tangent. So just like how sine and cosine can look similar depending on the period and the values you're looking at, tangent and cotangent can also appear to be the same. The last few questions that you have at the bottom of the assignment just are asking you to make some evaluations here. So I'm going to go through just a couple of those with you. We're going to start with number 18. So it says, what is the value of the function y? So understand that when you're asked what is, we are solving for the y value here. The function given tangent of x plus 90 degrees at 180 degrees. So this is my x value. What is the value of y? So plug in 180 for x. We end up with tangent of 270. And so we're just asked to evaluate this. What is the value of tangent at 270? So remember that tangent is y over x. 270 degrees corresponds here to the point 0, -1. And -1 divided by 0 is undefined. All right, so we'll look at number 22, and in this section, it is true or false with justification. So you do have to show how you came up with your true or false answer. 22 says 84 degrees is a 0 for the function y equals cotangent 5 times x minus 30 degrees. So if this is a 0, that means like an x-intercept. So is 84 degrees the x value here? So we're going to substitute that in. So we get cotangent of 270, and then we evaluate it. So do we end up with an answer of 0 here? So again, looking at 270, cotangent is x over y. 0 divided by -1 is 0. So sure enough, 84 degrees is a 0. So we can say that this is true. All right, so that is the end of our notes for Objective 11.